Welcome to The Explainer. Today, we're pulling back the curtain on artificial intelligence. We're not just talking about code, but something much more fundamental. We're talking about the blueprints, the actual architectural designs that power everything from the smart gadgets in your home to the most complex AI on the planet. Have you ever watched one of those robot vacuums navigate around your furniture and just wondered, what is going on in there? How does it know what to do? Or how does a chatbot seem to get what you're asking? Well, it turns out these incredibly smart feeling systems are all based on a few core designs. They're all what we call intelligent agents. So, first things first, we got to get this down. What is an intelligent agent anyway? Because this is the concept that ties all of this amazing technology together. Okay, so in plain English, an agent is just anything that can look at the world around it and then do something to change that world. Your robot vacuum, right? It has sensors, maybe a little bumper, that lets it feel a wall. And it has actuators, its wheels and motor, that let it turn and move away. It's all working towards a goal, getting your floor clean. It's really that simple. A constant, powerful loop. Sense, think, act. All right, so if that's what an agent is, how do you actually build one? How do you get from the idea of a self-driving car to a car that actually, drives itself? Well, you start with a blueprint, an agent architecture. The agent architecture is literally the blueprint for the AI's mind. Just like a house blueprint shows you where the kitchen is, where the bedrooms are, and how they all connect, an agent's architecture lays out all its internal parts, how it sees, how it decides, how it acts, and how all those pieces are wired together to get something done. You can really think about this in 3 layers. At the very top, you have the function. That's the big idea, the what. Something like navigate from point A to point B. Way down at the bottom, you have the program. That's the how, the thousands of lines of code running on the machine. But that all-important piece in the middle, that's the architecture. That's the blueprint that connects the big idea to the actual code. So what do these blueprints actually look like? Well, while there are tons of variations out there, most AI agents are built using one of 4 major approaches. Think of them as 4 different styles of thinking for an AI. And here they are. Let's meet the team. First up, you've got the logic-based agent, who we'll call the librarian. Super precise, follows the rules to the letter. Then there's the athlete, the reactive agent, all instinct, all reflex. After that comes the strategist, or the BDI agent, who thinks about its beliefs and goals to make a plan. And finally, you have the team captain, a hybrid model that basically tries to combine the best of everyone else. Let's start with our librarian. A logic-based agent works from a set of facts about the world, its knowledge base. To make a decision, it uses an inference engine, which is just a set of rules, to figure out the logical next step. The great thing about this is that it's super transparent. You can check its work. That makes it perfect for things like medical diagnostic systems. But, and this is a big but, it's slow. And if it sees something totally new that's not in its rulebook, it can just freeze up. It can't improvise. But what if you don't need a whole library of facts? This idea led robotics pioneer Rodney Brooks to say something that totally changed the game. The world is its own best model. He argued that instead of building a complicated internal map of the world, an agent should just react to the world as it is, right here, right now. And that's the philosophy of our next agent, the athlete. A reactive agent is all about reflex, pure instinct. It's built on a stack of simple if-then rules. If my bumper hits a wall, then turn. These rules are layered, so a higher level behavior like explore can take over from a lower level one like drive straight. This makes them incredibly fast and tough, perfect for a robot vacuum in a chaotic, messy room. The massive downside? They live completely in the present. They have no memory, which makes them absolutely terrible at any kind of long-term planning. Now, the BDI architecture is where things get a lot closer to how we think. It actually tries to give the agent mental states. It has beliefs about the world. My calendar says I have a meeting at 2 p.m. It has desires or goals, like I'd really like to grab some coffee. And most importantly, it forms intentions, the things it actually commits to doing. This lets it juggle different goals and make sophisticated plans, like a great personal assistant. The trade-off?
all that thinking, it takes time and is pretty complex to build.
So here you can see it all laid out side by side. The logic-based librarian gives you that transparent, verifiable syncing for a diagnostic system. The reactive athlete gives you the raw speed and toughness for a robot vacuum. The BDI strategist gives you that deep, deliberative planning for a personal assistant. And that layered model, our team captain, that's what you use when you need it all. Think about a self-driving car. It needs the lightning-fast reflexes of an athlete to slam on the brakes, but it also needs the long-term planning of a strategist to navigate across town. It combines layers to be both incredibly fast and incredibly smart. So we've got all these different blueprints. How in the world do engineers actually pick one? What's the difference between a good design and a bad one? Well, it turns out it's not just about the architecture itself, but about a few key design principles. And let's be super clear here. This choice isn't just some nerdy engineering debate. The blueprint they choose has a direct impact on us. Is the AI fast enough? Is it reliable? Can we actually trust the decisions it makes? Can we even afford to build it and run it? These are the real-world consequences. Probably one of the single most important ideas in all of this is something called modularity. And honestly, the best way to think about it is Lego blocks. You design the agent as a set of separate pieces that snap together. One block for understanding language, another block for vision, another for making decisions. This makes the whole system so much easier to build, to test, and to upgrade. If you want to improve one part, you just swap out that one Lego block. You don't have to tear down the whole castle. And that whole Lego block design helps with a bunch of other crucial things too. It makes a system scalable, so it can handle 1,000,000 requests just as easily as it handles 10. It makes it robust, so if one part has an error, the whole thing doesn't just crash and burn. And maybe most importantly for us, it can lead to explainability. It gives us a chance to actually understand why an AI did what it did, which is absolutely essential for building trust. Okay, so after all of that, what's the big takeaway? When you're choosing the right blueprint for intelligence, what's the secret sauce? Here it is. This is the punchline. There is no magic bullet. There's no single best architecture. It just doesn't exist. For a simple, fast job, a reactive design, the athlete is your best bet. For something that needs to be perfectly logical and verifiable, you go with the librarian. For a complex long-term problem, you'll probably need the BDI strategist or even the hybrid team captain. The choice is always, always about making trade-offs to find the right tool for that specific job. So I'll leave you with this question. The next time you're interacting with an AI, whether it's a chatbot, a navigation app, or even your smart vacuum, just take a second and think. Based on how it's behaving, what kind of blueprint do you think it's running on? Is it a lightning-fast athlete, a deep-thinking strategist, or a balanced team captain? Thanks for joining us on The Explainer.